Okay, so this is the Math at Work 11 lesson on compound interest. All right, so we'll get started. Last lesson, we looked at simple interest on investments or on loans. And today what we'll look at is compound interest. Okay, so we'll look at what compound interest is, what formula we use for it, and we'll do some sample calculations with it. Okay, so our key terms for this particular lesson, things we'll be using quite a bit, will obviously be what is compound interest, compounded annually, what a compounding period is, and then something called the rule of 72. So we kind of go through these briefly. We'll go through them a bit more in detail as we go through the lesson. But overall, compound interest is interest that is earned or paid on both the principal and any accumulated interest. So how that's different from simple interest is that simple interest, you only earn interest on the initial principal amount that you invest. With compound interest, you earn the interest on what you invested, and then if you earn interest on that investment, you can then earn interest on top of that interest. Okay, so you can earn interest on the interest that you've earned. So it's kind of money on top of money. When we talk about compounded annually, that's always the interest rate per annum. Okay, so you'll see that as well. So it's interest that is determined or paid once per year. So if something's compounded annually, it's only being done once a year. And what we'll be seeing throughout this is that not everything is compounded annually, right? Which is why we have this next definition here of a compounding period, because this is the time over which interest is determined, okay? So you might be given a 6% interest rate per year, but it's compounded semi-annually, which means the interest gets added on twice a year instead of just once at the end of the year, okay? So you're not getting 6% twice every year, right? If it was a 6% interest rate per year, you're not getting it twice, right, semi-annually. You're just going to get 3% of it in after 6 months and then the other 3% after that, right? But it actually helps you more because you're earning, if you do it twice a year, you've now earned a little bit interest, and then you get the 3% on top of the interest that you just earned as well in those last 6 months, okay? So anyway, with compounding periods, you have a few usual ones. Obviously, there's just compounded annually. You can get semi-annually, which would be twice per year. You could get it quarterly, so 4 times a year, monthly, so that'd be 12 times, weekly, 52 times a year, or daily, right? So you can get interest that compounds every single day, right? 365 days a year, okay? And then what we have as well is our rule of 72. And the rule of 72 is just a quick little way to figure out how long it would take your principal investment to double, okay? There's a few issues with this, and just in the sense of, you can only use it in certain situations. For instance, it can only be used when it's being compounded annually, right? And you actually use the percentage instead of the decimal, which is kind of against everything else that we've been doing, so just keeping that in mind. But overall, what you just do is you take 72 and you divide it by what that annual interest rate is, and that approximately gives you how long it's going to take for your investment to double. All right. So, as I mentioned, your key aspect of compound interest is the fact that interest is earned on the principal plus any interest previously earned. So, for example, if we invest $100 compounded at 10% annually, then in the first year, you would earn $10 because 10% of $100, right, so 100 times 0.1 is $10. So at the end of the first year, you now have $110 in your bank account. Now, when we did this lesson with simple interest, it would mean that you'd only get the 10% off the $100, so you'd only get the $10 every year added in, right? So you would go from 110 to 120 to 130 to 140. However, with compound interest, every year they look at, well, what's in your bank account now, and let's give you 10% of that. So after that first year, you earned the $10 in interest, so now in your bank account is $110. So since it's compound interest, they then say, all right, well, you're at a rate of 10% compounded annually, so now we'll take 10% of what's currently in there, right? So that would be 10% of $110, which is $11, and then the $11 gets added to your bank account, and now you have $121, right? So if that was only in simple interest, you'd only have 120. With compound, you have 121. Now, I know that doesn't seem like a lot, but keep in mind that a lot of times we're investing money for more than just 2 years, right? You're usually investing it for a lot. And then if you are compounding it on a more consistent basis, like if it's being compounded multiple times a year, then it's going to really add up, okay? So yeah, with the simple interest being only on the principal amount invested, right? It's just a constant amount of money every year being added to your account. It's never going to change. Okay, but again, with the compound interest, you might only be able to start with a small amount, but as it grows, you'll earn interest on the bigger amount, which is an advantage so that you don't have to come up with a big lump sum to start with to try and earn more interest. Okay, so compound interest, if you're ever kind of looking at savings accounts, an account that's going to offer you a compound interest rate is going to be better in the long run for you. Even in the short run, slightly, but even in the short run, it will be better because you will earn more money. But keep in mind as well, if you're borrowing money and it's at a compound interest rate, it means that you'll ultimately be paying more money back. Okay, so it kind of does work both ways there, so just keep that in mind. With our compounding period, right, so again, what happens is they give you an interest rate and they'll always state it as it's this much annually or this much per annum. Okay, so that just means annually. So they'll give you the interest rate, it's so-and-so invested this much money at 3.2% per annum, compounded, and then fill in the blank, right? So it'll tell you what the interest rate is per annum, but will also tell you how often it's being compounded. So it'll say either just compounded annually, so just once per year, or it'll say semi-annually, which means twice per year, right? So it gets compounded twice. They do those calculations 2 times every year, every 6 months. It could be quarterly, right? So there you would do those calculations 4 times per year, so every 3 months. You could get it calculated monthly, right? 12 compounding periods per year, or even daily, 365 compounding periods per year. Okay, I did include everything in here. I mean, weekly would be 52 weeks, bi-weekly would be 26 weeks. You would just kind of have to look at your calendar and figure out how many compounding periods that would be. Okay, but that's going to be a key part of the formula we're going to be dealing with. So, with calculating compound interest, so since the compound interest is earned on the principal and the interest earned, the amount of interest that you actually get is different every compounding period, right? And it means that the amount of principal that you're taking the interest on also changes every compounding period. So if you wanted to do these calculations by hand using like this formula that we were kind of using with simple interest, right? We're like, well, let's figure out what 10% of this is and then add it on to the original, okay? And then now we have a new amount, okay, well, what's 10% of that? And then figure out that and then add that on to the original. And okay, now we have a new number, that's 10% of that, and then going and going and going. And I mean, it's not bad if you're only doing it annually for, let's say, 5 years and it's maybe only 5 calculations, but what if you've got something where it's an interest account that's being compounded monthly and it's asking you what's its final value after 20 years? That's going to be 240 different interest calculations. That's ridiculous to try and have to do step by step by step by step. I mean, don't get me wrong, we could do it. If we're really handy with like an Excel program or a spreadsheet program, we could set up kind of the cells to be set up in such a way where it's like you take the number, take the cell before it, find 10% of it, put it in a new cell, add it to the other column, right? But again, that's still rather time consuming to at least set up all those things. What we have instead, because this is a lovely little math class, is we have a compound interest formula. Okay, so the easier way to deal with these situations is just to use something that we call just the compound interest formula. And because you're earning interest on top of interest, this is kind of a type of exponential growth, right? So what you see here is in the formula, this part here, the NT part, that's actually an exponent, okay? So in that formula, right, your future value, I have a typo in my slides, I'm realizing that now. The interest, so I'm going to edit this right away because I don't want you to get confused with it. What we need to put in here is a value of P right in front. Okay, so now we're good. So A ends up being the future value of the investment. Okay, so that's how much money you're left with after a certain amount of time. P, in and of itself, is the principal amount that you've invested or borrowed. Okay. All right. Basically, this calculation here, like without the P, the 1 plus the R over N to the power of NT, that's going to calculate how much interest you're earning, okay, over that period of time, and then you'll multiply by the principal amount to get your future value, okay? So Again, if it's just asking you for what interest was earned, right? If the question is just asking what interest was earned, don't worry about the P and just worry about this part, right? But if you are asked about what is the future value of the account, how much money is in the account, or how much money do you owe back after a certain number of years, that's when you're using the P that's out front here. Right, so P is representing your principal amount. You notice you've got three other variables here. R is your interest rate per annum, or your annual interest rate. They'll tell you what that is in a question, right, where you'll be able to plug that in. N represents the number of compounding periods per year. So go back, reference that slide if you need to. If it's being compounded annually, then this value is just a 1. If it's being compounded semi-annually, twice a year, then this becomes a 2 because that's 2 compounding periods. If it says it's being compounded quarterly, then this value of n here is a 4, okay, etc., etc. Now up here in the exponent, you have two variables, nt. This means that they're multiplied together, okay? So the entire exponent, you'll need to figure out what the exponent is supposed to be by taking n, the number of compounding periods, and multiplying it by the number of years. So in that last hypothetical example that I talked about, something being compounded monthly for 20 years would take us 240 interest calculations. How I got that value was I said, well, number of years was 20, so my t value here was 20, and n was the number of compounding periods per year. And if it was compounded monthly, it means you have 12 compounding periods per year, so 12 times your 20 years is the 240 compounding periods. Okay, so this here should represent not necessarily the number of years, it should represent how many times the interest is being compounded over a particular term of the loan or the investment. Okay, all right, so let's get into some examples. So the first one here is calculate the interest you would earn on $1,000 deposited in an account that pays 4% interest per annum compounded annually if you left it for 2 years. Okay, so with this, switch over, I'll do this one up on the board. Okay, so you've got $1,000 that you're investing, so your principal amount of your investment is $1,000. Okay, your interest rate per annum was your 4%. It said it was only being compounded annually, which means your n value, your number of compounding periods, is just 1, right? Because it's only happening once per year. And your value of t, which is your time in years, was 2, okay? Because it was being done for 2 years. So, using our formula, A is equal to P times 1 plus R over N to the power of NT. Right, we can start plugging in the values that we have. So our P is our $1,000. So that goes there. 1 plus. Now, the value of R needs to be not as percentage, but as a decimal. So remember, to go from a percentage to a decimal, divide by 100. Okay, so that would be 0.04 divided by 1 to the power of, and I would need to multiply 1 by 2. Again, we're just going to show all these intermediate steps, at least here for the first one. Okay, so remember your order of operations laws here, right? So brackets first, figure out what's happening inside this bracket. What is 1 plus 0.04 over 1? Okay, so within the brackets itself, you need to do this division first. 0.04 divided by 1 is just 0.04, so this would become 1 plus 0.04, right? And then up here, this 1 times 2 is going to be 2, right? The 1 plus 0.04 is 1.04. So you have 1,000, 1.04 to the power of 2, right? Again, don't forget your order of operations, right? So we dealt with what was inside the brackets. We simplified that exponent. Now we have to do exponents before multiplication. So you have to do 1.04 squared, or 1.04 to the power of 2 first, right? Calculate that, 1.04 to the power of 2. And again, I'm going to show this intermediate step just so we have no confusion. So we calculate what this is, and it's 1.0816, and now I can multiply that by 1,000. Okay, so overall, we get $1,081 Okay, so that would be our future value in a compound interest account after 2 years. If we were asked, okay, well, what was just the interest earned? We'll just subtract the difference here, right? If your future value after 2 years is $1,081.60, and originally you invested $1,000, well, how much of this is interest? Well, whatever the difference is. So you ended up earning $81.60 in interest there. Okay, so that's where that value is going to come from to help you figure out just the interest. So you still use that formula, and then away you go. All right, so that was your answer to part A, where it was asking you how much are you going to have in that account under those conditions. Okay, if we go back to part B, it then says compare this to what you would get at the same interest rate over the same amount of time, but with simple interest. Okay, so we're going to kind of keep that number in mind, that 1,000, actually I'll write it down. So from part A, our answer was $1,081.60. But now what we want to do is use those same values and see, well, what would happen if I did this with simple interest? Okay, so this kind of goes back to our last lesson, where again, the principal amount is still $1,000. The rate is still 4%, which is 0.04 as a decimal, and our time value is 2 years. Okay, so from our simple interest formula, our future value was equal to the principal plus the interest earned. The interest earned came from taking the principal, multiplying it by your interest rate, and then multiplying it by the time. So this would be 1,000 plus 1,000 times 0.04 times 2. All right, so we do that calculation, 1,000 times 0.04 times 2. So the interest earned would be $80, and that would be added to the 1,000. So in total, you would have $1,080. So when we do that comparison, right, with compound interest over 2 years, it was $1,081.60. With simple interest, it was just $1,080. Right, so as of right now, no, it doesn't look like one's really more advantageous than the other. $1.60 doesn't seem like a huge amount of money. However, over a longer period of time, it's going to add up. Okay, so I just kind of copied and pasted the solutions here as well, just so that if you wanted to just not have to watch the video again, but instead just look at the notes, they're here. Okay, but that's that. And like I mentioned here, I made a little note there that says, the longer that you leave the investment, the more it's going to earn through compound interest compared to simple interest. Okay, and that's just going to be the way it is. All right, now we'll look at what happens if we compound it over different periods of time. Okay, so let's calculate the final value of a deposit of $1,000 again, invested at a rate of 2.8% per annum for 4 years under the following compounding periods. Okay, so we're going to basically take the same principal amounts in each situation of $1,000 for all of them. And the interest rate is always 2.8% per annum over 4 years. Okay, so I'm writing in that my R value, my interest rate value, is my 2.8%, which as a decimal, if I divide that by 100, is 0.028. And then my time value is 4, and that's going to stay the same for all the calculations, but what changes is the number of compounding periods, right? That value of n. Okay, so for the first one in A, semi-annually would mean that our n value is going to equal 2. Okay, so I've got that already set up, right? So in all the situations, we can leave all this at the top. So the principal amount invested was $1,000. The interest rate was the 2.8% per annum. So I divided it by 100 to get it as a decimal, 0.028, and it was over a period of 4 years. The first question said, what would you get after, if it was done semi-annually, which meant twice a year, so your number of compounding periods is 2. So again, we set that formula up where the future value is equal to P times 1 plus R over N to the power of r times t. Okay, so our principal amount is 1,000, right? Interest rate was 2.8% per annum, right? That's per year, but this is happening twice per year. So you're basically getting this in total. So we have to cut it in half because we're doing it twice within the year. So twice within the year should add up to this, which is why we take that interest rate of 0.028 and we divide it by 2. And then that all goes to the power of r. Oh, sorry, that's not r. That should be an n. Oh, silly me. Okay, n times t, so 2 times 4 up here. Okay, so we can combine a couple steps here. I won't maybe show as many as the last one. All right, but again, what I can do here is do my 0.028 divided by 2. Okay, that gives me 0.014 and then add it to 1. Okay, so altogether that's 1.014. And then that's to the power of 2 times 4, which is 8. Okay, and then remember you have to do the exponent first. So you would do the 1.014 to the power of 8. So what you'd get is 1,000 times 1.1176, and that kind of keeps going. Okay, but you know, try and keep as many as you can, right? So in reality, this is 1.1176444383. What I suggest doing is kind of keeping that number stored in your calculator, and instead of rewriting this, right, you can just kind of keep that stored and then just take that number and multiply it by 1,000, right? And then you can round to your 2 decimal places because we are dealing with money, so dollars and cents is as max as we're going to go, right? So this gives us a value of $1,117.64. Okay, so there's our value for A. Okay, so I'm going to write that one down just kind of to keep track of it because we are trying to compare them. So I'm going to keep A listed here, 117.64, and now we'll go and take a look at B. So with B, same thing, right? Let's go double check what the compounding period is for part B though. It's quarterly. So all the same values apply, except now the n value in this case is going to be 4 because it's being compounded 4 times in the year. So using that same formula, okay, principal times 1 plus the interest rate divided by the number of compounding periods to the power of basically total number of compounding periods, which is so 4 times a year for 4 years, that value is going to end up being 16. Right, so if we do this, my principal amount was again the 1,000, 1 plus my interest rate split up over 4 times, so that 0.028 divided by 4, all to the power of 4 times 4. Okay, so again, this can get calculated. You can do this all in one step. 1 plus 0.028 divided by 4. Get 1.007 to the power of 4 times 4, which is 16. And again, as long as you make sure that you do this exponent part first, you could just do this all in your calculator, right? But just making sure that the brackets go kind of here, right? Where you're doing 1,000 times bracket 1.007 to the power of 16 end bracket, and then what you can get is a future value of $1,118.08. Okay, because it's 0.076. So we'll put that as 8. Okay, so for B, we get a little bit more money there with 1118.08. And then finally we can look at C, which I think has us compounding monthly. Yeah, so monthly, that would mean that our end value is going to equal 12. There's going to be 12 compounding periods. Okay, so that interest rate is split up over 12 periods. So what we get here, using that same formula, there's the $1,000 multiplied by 1 plus 0.028 divided by 12 to the power of 12 times 4, right? So that would be 48. So again, calculate that. 1 plus 0.028 divided by 12. So that's 1.00233 repeating to the power of 48, right? So you take that value to the power of 48 and then multiply it by 1,000. I've been keeping everything just stored in my calculator, okay? So I don't actually rewrite this or retype that in. I just leave it stored and then say answer to the power of 48, and I get an answer, and then I take that answer and I multiply it by 1,000. So if you're getting values that maybe are a few cents off, that's probably why. Okay, and overall this value is 1118.37. Okay, so now we have all three. Okay, so again, the thing that I'm hoping that you notice is the more often you have something that's compounding, right, the more compounding periods there are, the more money you actually end up with, right? Again, over this small period of time of just 4 years, it's really only, it's not even different by $1 going from semi-annually compared to monthly. Okay, but again, the longer you leave it, if you're talking about an investment that's being invested over the course of, let's say, for your retirement, and you start investing when you're 30 and you invest until you're 60, right? You've got 30 years of investments there. It's going to make a bigger difference. Okay. All right. Where are we at now? Okay, so again, I've included the answers to those in the slides. If you don't want to look back at them, you get the same answers. There's your 64, 1808, 37. So again, you do notice those slightly different values here. They actually have a mistake in this by the looks of it, because they have 12 times 4 is 16, which is not right for some really odd reason, or know what they've kind of missed these up. So I'm just going to go again and delete that, and I'll edit that in, but essentially what you've got is the more compounding periods, the greater the future value. Okay, last thing to talk about in this lesson is the rule of 72. Okay, so again, that rule of 72 is a quick way of just calculating how long it's going to take your investment to double under compound interest if it's compounded annually. And the formula for this is just 72 divided by the interest rate, but you keep the interest rate as a percentage. Okay, so because the rule of 72 is just an estimation strategy, we don't have to be exact in those, convert your percentage into a decimal. You can just leave it as it is, okay? And that'll give you and just 72 divided by that number, okay? So in this one, it's asking us how long will it take an investment of $5,000, right? So our principal amount is $5,000, invested at a rate, so our value of R is 3.75%, right, per annum compounded annually to double in value. Okay. Again, rule of 72 does have that little kind of caveat with it that says it only works when it's being compounded annually. If it's being compounded monthly, bi-weekly, daily, it's not going to work as well. Okay. But if we go and do this, it's just a simple calculation here, right? So we've invested $5,000. We want to know when that's going to double to turn into $10,000. So using the rule of 72, all we do is we take 72 and we divide it by 3.75. And you get 19.2, and that always gives you a value in years. Okay, so you'll always just kind of round to the nearest year. This would be round down, so it's about 19 years. Okay, so from here, we're just basically saying, all right, well, if I've got $5,000 invested at this interest rate compounded annually, it's going to take me 19 years for that $5,000 to turn into $10,000, right? That's provided you don't put any more extra money in it, okay? So that's just your rule of 72. Okay, and that one actually is correct. Okay, so I will make that edit to that third one that's incorrect, fix it up, and I'll post those notes. And for you to work on, I have created a compound interest worksheet very similar to the problems that we've just done on the board. So use those as kind of a model, and you'll complete those questions and submit them for feedback and marking. Okay, and again, any questions, email me at any time, or if you're still confused, schedule a Google Hangout Meet call with me, and I'll put it out there for anybody who's interested in. Okay.